అగ్గిల్ని ఒక్కసారి అరవడం ఆపుతాను. PPT? They'll see on the screen, no? Okay, no? Hey, please. Right. Yeah. Is it visible for you all?
Yes. Yeah, it's visible for us.
If not, please let me know. Then otherwise, I'll go with the other PPT. See, electromagnetic waves, basic characteristics which we need to learn, which are there in the syllabus. Dear friends, hello, Aditya Rana, you people did not have the class. Once you have it again. Of course, before time you are there. Measuring the speed of light. How to measure the speed of the light is there in our syllabus. Okay, it means it is you are not going to any measurement and all. There is no brainstorming picture here. There is simple formula C equal to 1 by under root of mu naught epsilon naught is there. Okay, so with respect to that, if you substitute this value, C equal to you get 3 into 10 power second. So whatever this value is there, that value is equal to the velocity of light. That's why electromagnetic waves are traveling with respect to the speed of light. Now, there are small things, energy in EM waves and radiation pressure and radio and television waves, how we will use in a communication system. These are the important things for us because questions will be asked on that basis. See, there are the people are seeing in the textbook, they are confusing. This all first part is not there. If you see in NCERT book, 8.3 hours you are supposed to read. From there, 8.3 onwards you are supposed to read it. Okay? Now, you can also have it. This is all before it was not now. You don't have anything in this. Just you should go with the we have velocity equal to ratio of electric field by the magnetic field. This comes from the velocity selector. If you have any problem from the back, you can sit on this side. Okay, V equal to E by V. Now from this only we will get the formula whatever I said. C equal to 1 by under root of mu naught and epsilon naught. This gives the velocity of light. Now, the magnitude of this speed, which is equal to 3 into 10 to the power of 8 meter per second, that is also equal to the speed of light. Is having the basic property. The velocity of light always E equal to n into lambda or f into lambda we can write. This is applicable for all type of waves, this equation. Okay. Same way it is applicable for the electromagnetic waves also. And next,
So what is lambda?
lambda is a wavelength, f is a frequency, where v is a velocity of light. Usually that we will indicate with the c. Ray optics. Ray optics is most weighted topic because in this hardly very less amount of topics has removed. So therefore you have reflection of light onwards everything is available and it is also scoring chapter which is easy from 10th standard you are learning this. Okay. See you can see that now here. Refraction of light onwards you are going to study. Okay. Now it's visible now. It comes in a there also no. Refraction of light. What do you mean by refraction of light? First of all, a phenomenon of bending of a light whenever it has crossed the medium. Phenomena of bending of a light whenever it has crossed a medium is called as refraction of light. Usually this happens because of the optical density of the medium. Because of the optical density of the medium it happens. In this, since there is a optical density difference is there, therefore speed of light changes always. This is very clear for everyone. That's what we are high side is will be settled. This is rarer medium, denser medium. It is bending at the denser medium you are finding here, right? So nothing but it is changing because of the density in this medium is more than this medium. At the same time, in this medium more, it is less. That's why it is moving away from the normal, it is moving towards the normal. These are the points look smaller, but 2 mark questions it makes lot of difference. What are the reason why it is behaving like this in the sense? Because of change in the medium, because of the refraction of the light. Laws of refraction. What are the laws of refraction? We can see here at the point of incidence and the refracted ray lies on the same plane. Means when you are drawing, this must be lying on the same plane. That's why this is we can say that all the light rays are when you are drawing, it's supposed to be on the same plane of the paper. Okay. Next, you are having the Snell's law. What is Snell's law? And that is also is the second law of refraction. When light ray passes from one medium to another medium, obviously it changes its direction, right? Therefore, we can say the ratio of action is constant. Okay. From this, we have you can see that Snell's law mu equal to sin I by sin r. We can say. Okay. Mu equal to sin I by sin r. which is equal to constant, where u can be taken as constant always. These two laws important. Tomorrow there may be a 2 mark question can come. State the laws of refraction. State the laws of refraction. You whatever you are knowing, you should not explain. State in the sense it must be a statement. So we have to state it very properly. Are you understanding, everyone?
Yes, sir.
Statement must be its statement. That's why we need to read it. Then next. So after the laws of refraction, there are some important tips in the refraction. What are the important tips which makes the difference in the refraction? First, as I said, the mu of optical medium. Who is a mu? Mu is a refractive index. Mu is a refractive index. Right? Now, at the same time, this mu is denser medium will take more bending with respect to the rarer medium. Okay, means refractive index is more for the denser medium than the rarer medium. For example, if you see the value of the refractive index of the air is equal to mu air equal to mu vacuum equal to 1 we have written. Actually, this is not 100% equal to 1. Mu vacuum equal to 1. But coming to the of atmospheric refraction effects, whatever you are seeing, the sun appearing at different position and stars appearing at different position, this all happens because of the difference in the refractive index of the air as well as refractive index of the vacuum. Now, in refraction, the velocity and wavelength of light changes whenever it changes its medium. Remember here, most important point ever, frequency will not change. Frequency depends on the source. Okay? Who will change? Velocity of light and wavelength of light changes. Tomorrow question can be asked. Question can be asked. Why color of light has changed? Because of velocity of light changed. Because of wavelength of light changed. Why velocity of light changes? Because of optical density of the medium. Okay? Now, in refraction, the frequency and phase of light do not change. In refraction, frequency and phase of light do not changes. As I said, only wavelength and all, wavelength and as well as velocity of light only changes, whereas frequency will not change and phase also will not change. What is the phase here? Can anyone? Or motion of the wave. Remember, direction or motion of the wave, it describes the phase. In a medium, it gives the refractive index definition. They'll ask you the definition. When light passes, the ratio of the velocity of light in air to the velocity of light in a medium. It gives the absolute refractive index of the air. Please note down this point. Refractive index definition. It is the ratio of velocity of light in air to the velocity of light in a medium. Next, most important thing is the principle of reversibility. What is this principle of reversibility? Reversibility of light, it is a phenomena. Okay, it is all the time natural phenomena. Sometimes it may not natural phenomena. You can see here a light coming from the air to the denser medium. Let us say water. In this, I kept this is a plane mirror, such a way that light should be reflect back along the same path. You getting my point? Mr. Aditya? See, I kept the light plane mirror such a way that it should be reflect back. So whatever the light has refracted here, it's going back along the same path. That means here whatever the angle of incidence is there, for reverse path it acting as a angle of refraction. Whatever the angle of refraction is there, that acts as a angle of incidence for the reverse path. Therefore, you can see here Snell's law. When light is passing into the medium, A to mu B, sin I by sin R. Now that will be reversed here. Look at here. B mu A, sin R by sin I. Why I need to tell this topic in a sense? From this we can understand when there are two refractive index mediums given in the question paper. They'll ask what is the total refractive index of the medium. Okay, then that time you can use this concept. Mu AB into B mu A, which gives us 1 plus 1 in the sense it is reciprocal to 1 to other. That's why we are getting the answer equal to 1. If you multiply these two, sin I get cancelled now. So that's why it gives a 1. We say it is. Now, you can also see not only this, refraction through parallel slab. How refraction takes place through parallel slab. Parallel slab, we have only activity oriented experiment in the 12th. But questions can come in the examination. It is a 10 standard. No. Here we need to follow the formula also. Look at here. This is a glass slab. This is a glass slab. So having thickness T, then therefore the light which is incidenting it refracts and it emergent out. Now you can see here the dotted lines which are extending the from incident light ray to straight. That gives the straight path from the emergent path. The distance between light which you are extended, that is called extended path. Comparing with the emergent light ray, how much it has shifted from here to here. The distance, if you are taking perpendicular distance, that we call as lateral shift. What it is? Lateral shift, lateral displacement we call it is. Right? Not only that, you can see how it has shifted. Same as Snell's law, that gives when light passes from one medium to another medium, which gives the equal to 1. Since if it is I1 equal to R2, means this angular sense I1 equal to this emergent angle, then there is no deviation to the glass slab. Okay? Lateral shift. How to say that lateral shift? Lateral shift formula is what? Why we are using this formula? Lateral shift T into sine delta by cos R1. From this diagram, look at here. This is the angular deviation. With respect to this, we have written T stands for thickness. If thickness of the slab changes, what it changes? The shift, the lateral displacement changes always. Okay. Now, cos R1. For example, angle of refraction is changes, then there is a change in the lateral displacement. Means either this angle or this angle if changes, there is a change in the lateral displacement of this path. This distance changes. For example, these two constants they are not changing. But if you change the thickness, if you change the thickness, then automatically there is a chance the shift also can be changes. The shift also can be changes. Now the same form I can interpret in the form of T sin I minus I1 minus R1. Means I1 minus R1 gives the delta only, no? That is by cos R1. This is the cos R1. These two are the most important for the JEE mains also. Because whenever any medium has given, any thickness has given, through the thickness when you are allowing, then one of the shifts in the image, then we will understand. What is the shift? We can understand. Right? Now, these two important formulas, how much the light ray has changed its path, deviated